George, Natalia, Sahar, and Asmita. Thank you all so much for joining us. I think this is everybody. We're missing one person. We're missing Sam. And here he is. Oh man, Sam, you were the most important
Here he
person.
is.
I added you last. All right, well, I'll let you all take it away. Thank you so much for joining us.
All right. Hey, thanks so much, Lily. I am in hearty agreement. This is a very exciting topic and one that I get a lot of questions and comments around. Hey, LLMs are super exciting, but how do we actually build products around them? And that is what we're going to dig into in this panel. I will quickly introduce our panelists so that we can dig right into the heart of the discussion. We've got Asmita Rathis. Asmita is a machine learning engineer at PromptOps, where she's applying LLMs to enterprise observability for DevOps engineers. We've got George Mathew. George is the managing director at Insight Partners, where he's invested in companies like Weights and Biases and Fiddler. We've got Natalia Barina, a former AI product leader at Meta, where she focused on issues like transparency, control, and explainability. And we've got Sahar Moore, who's currently at Stripe, where he's leading the work around making LLMs a thing at the company. I am, of course, Sam Charrington. I am host of the TWIML AI podcast. If you've not come across the podcast, I encourage you to visit twimlai.com or your podcast platform of choice and check us out. We've got 600 plus episodes on ML and AI, including lots on LLMs and generative AI for you to dig into. I asked our panelists for their spiciest takes on LLM, and we've got some really interesting responses there, and we're going to start there just to get we'll start it spicy. Natalia, why don't you kick us off with yours?
Yeah, my spicy take is that LLM hallucinations are a feature and not a bug. Why people lie? We can't verify even what people say. So why do we expect that we'll be able to verify what machines are saying? And how can we even differentiate truth from lie? There's a lot of gray area in this. The other part of it is I don't think we'll ever get rid of hallucinations. It's a fool's errand to try. Instead, the right thing to do is to use LLMs for the right use cases where they can shine. And in particular, that means around creativity and inspirations. And that's my hot, spicy take.
Awesome. Sahar, why don't you go next?
Yeah, first, I also agree with Natalia that hallucination is going to stick around for some time. So we need to have great ways to mitigate those. So on my end, I actually think that open source language models are the future. We got this recent paper from Berkeley about the false promises of open source LLMs. But at the same time, since Meta's release in last February of Llama, we can think about how open source LLMs can be quite powerful. So first, they can run at the edge, which is a great fit for everything that is privacy-related use cases and also independent of internet connection. We have great work like MLC LLM and also Llama CPP that gets us really close to being able to run these amazing technologies at the edge. Developers can fine-tune them for specific purposes, so you can achieve better performance for less compute and less latency. And they also give you a lot of flexibility without predefined constraints or policies, which is sometimes an issue, for example, when you use the OpenAI API. And licensing is no longer an issue. We got some really strong, powerful LLMs that are now commercially permissible, like Falcon. And Microsoft released this paper, Orca, a few weeks ago that basically shows how smaller LLMs and open source LLMs can also perform well when you imitate the right things and not necessarily the style, like maybe other open source LLMs. So an exciting futures, and looking forward to see what people will do with those open source LLMs. Yeah.
Asmita?
My spicy take is that, we're all here because of the generalized LLMs. Everyone's talking about it. But I think the future is going to be very domain-specific, specialized models, where each company, each organization's data, their proprietary data, is going to be the key going forward. Everyone's going to have their own data, have their own specialized models, and they're going to release these as a model as a service, where the proprietary data is going to be the big thing.
Awesome. And George?
I love how all of our commentary is like somewhat interrelated to each other. Mine is that we're going to run out of public corpus to be able to train these large language models at scale. And that's going to happen in the next half a decade when, let's just say, the GPT-5 style models start to emerge, mainly because, we're approximately training on 20% of the human corpus, and we've exponentialized every last run of generative pre-trained model at scale up to this moment. So if there's another 10x happening in terms of where the extent of the training data is going to come into training the next generation of model, we're literally going to run out of publicly available human corpus. And so coming back to Askipa's point, as well as Sahar's point a moment ago, we are going to move to a world where private data, particularly on smaller form factor large language models, likely emergent around open source, which is where some of these small form factor large language models are most relevant, is where this sort of half a decade and beyond is going to go for the future of building transformer-based architectures.
Now, are these spicy takes so spicy that there's some argument that anyone on the panel would like to pick on any of the takes we've heard thus far, or anyone in the audience for that matter? Anyone jumping out to disagree?
I guess I could go. I'm not disagreeing, but there is another point that there are open source models, like companies where, like right now we're seeing so many companies out there that they're not training these models, but they're using LLMs into their products without a huge ML team, right? There's no management of your training, your whole ML pipeline, your whole ML infrastructure. And with these open source, like these APIs that OpenAI, Cohere have, it's so easy for these companies that don't have an ML expertise to include LLMs into their product. So I do see it coming from that side too.
There's a role for services.
Yeah.
Got it.
Yeah, I think if we were taking the other side of this argument, you could make the case that, hey, the quality of these smaller form factor open source models might not be ever as good enough as the large research houses and what they're effectively producing. And over time, the research houses that are producing these large language models are going to have additional capabilities, like the function libraries that emerged, like the plugins that emerged about a few months ago, where there's just going to be a general arms race where the open source community and the use of, call it the sort of public data sets is not going to be enough. And you're going to see, the research houses take on a lot more workload when it comes to leveraging private data, multimodal sets of data. And there's likely a chance that sort of the things that are kind of being predicted, at least as we indicated, could have an alternative future. So you could kind of argue very easily for the countervailing point here that this is all going to stay very much in the hands of 3 or 4 well-funded research shops, being OpenAI, Cohere, Anthropic, AI21 as the continued leaders in this space. But it doesn't seem that way right now. It does seem like there is a prevalence towards smaller form factor models and open source in particular.
Actually, just maybe adding on that is if we look at timeline. So I actually think that at some point open source models will be good enough. So now we have GPT 3.5. We already have models reaching this level of performance. So maybe in 1 year from now, we will have a GPT 4 or even more than that potentially. I know it's kind of hard to think about it at this point, but if we take history so far and we believe that some of those papers about open source models achieve this performance, so I think it's a matter of time we get there. And then the other question is, potentially, as we are building products in production, what are the requirements for such products? Do we actually need a GPT-4-like model to do question answering on documents or answer very specific questions? So I think that as we build more picks and shovels in this space, we improve on evaluation, we better understand what are the use cases we would like to serve, we can get to better results even with smaller and open source models. But this will be an iterative process for sure.
Well, we'll touch on all of those themes and in particular model selection a little bit later. I want to take us to one of the very first issues that a product builder needs to think about, and that is the degree to which their use case is a good fit for LLMs. Right now, LLMs are this shiny magical hammer and everything is a nail just waiting to be smacked with it. But Natalia, you've got some really interesting experiences thinking about applicable use cases for LLMs and AI generally. And I'd love to hear you chime on what you've, frameworks for thinking about this. And in particular, are there kind of recurring use cases that people get excited about that are ultimately doomed to failure because they're not a good fit? If you want to throw that spicy take in there.
Yeah, absolutely. So I think I would start off by thinking about what are the fundamental characteristics of LLM that really make them shine. And it's really about fluency. So this is why LLMs are a big deal and why everyone's excited about them. They have this uncanny ability to give answers that are surprisingly human-like. This is why we have so much hype. And that's really what fluency is. It's the ability to articulate very natural sounding answers that are human-like. And that is their strength. However, on the other hand, as we have already touched on, we have also hallucinations, or as other people like to call them, confabulations, where LLMs sound perfectly plausible, however, can be disastrously wrong. We can't trust them. And so a good way to think about a framework for use cases is around two axes. And you can visualize the accuracy axis kind of on X, so it's your horizontal, and think about fluency as your vertical axes. And then if you could kind of map your use cases along those two lines. And if you do that, you will see that places where you don't need accuracy, but you need fluency, and you really benefit from LLMs are things like writing a greeting, writing poem, writing fiction, writing children's stories. So these are really creative use cases where you need lots of inspirations. Then you could think about, on the other end, you might have use cases where you need a lot of accuracy, but you don't need fluency. So these are really about being precise on the information and getting the right answer. So really, to me, those are kind of the two buckets, the creator and productivity use cases versus the second bucket, which is more around decision-making. So I'd consider, where do your use cases fit along those two lines? And once you map them, I would recommend thinking about, what is your business decision framework? And there's really a few aspects of that. And they are, well, are LLMs going to make your business obsolete? Go all in and invest. 2, can they boost your revenue? So this might be customer support, call centers, etc. Then you have to think about, do you build or buy? 3rd, can you get a competitive advantage? And this is like that vertical scenario where that is beautiful. And I can't wait to see those come to fruition. And then finally, you might be in a position where you just, LLMs make no impact to your business and product, and you can experiment, but you don't really need to apply them. So those are the two kind of frameworks. One is around use cases, and then the second one is around making that business decision and seeing what your situation is before making an investment or before even beginning to experiment, which I highly encourage everyone to experiment. That's pretty cheap. And then that's where I'm going to conclude.
Anyone want to jump in and elaborate?
Yeah, maybe I can add a few to my 2 cents. So from my experience, that's right, but also elsewhere, I feel like the biggest gap that will make us work more with LLMs or even feel more confident, it actually, again, like evaluation. So in the world, let's imagine a world where every time we change the prompt, we can immediately know how it performs on like bias, toxicity, how often does it hallucinate, and also how it correlates with our own performance and benchmark. Then I will feel a lot more confident deploying something like this into production. So in a way, it reminded me of how like deep learning and machine learning was like a decade ago, where it was really we were all like a bit scared to deploy something to production because it might yield a result we don't expect. But then evaluation, monitoring, like what we now call ML ops, really made it a lot more easy and streamlined, and therefore increased confidence in deploying these kind of applications.
Yeah, that fear is a real element that I see a lot, particularly on the part of, product owners, executives. They, it's easy to get enamored by a ChatGPT demo, but when you think about the brand risk that's possible when your LLM, your customer-facing LLM starts, hallucinating publicly, it really put some pause, and especially with the evaluation frameworks not fully baked. Has anyone come across any useful ways to kind of drive team alignment and alleviate that kind of fear? Natalia?
I would recommend, I'm going to plug for my own work, but one of the things we developed at Meta was something called an AI system card. And it's essentially a way to publicly report on the risks and to present the evaluation. And actually, this is what ChatGPT did, or OpenAI did with the latest version of GPT, is they published their AI system card, and they literally went through and they said, okay, this is how we looked at all the safety risks. This is how we evaluated toxicity. It's a very exhaustive document. There's 40 pages. There's a lot in this space. And the other thing I would say is, you have to think about evaluation is expensive. Evaluating your AI products is going to take time. It's going to take resources. So you have to figure out how much can you do, but I think everyone should absolutely do it. And I encourage everyone to go through and look at the GPT-4 system card, which is a really good guide for a very comprehensive evaluation of an LLM and all sorts of issues that can go, we mentioned privacy, security, just robustness, bias, toxicity. There's so much in here. There's a lot to do.
Yeah. Prompting has obviously been raised quite a bit at this event so far, and it's core to LLMs, and it's in a lot of ways a new way to create software and systems with a rule book that's being developed as we speak. Asmitha, can you talk a little bit about your experience with building prompt-based applications?
Sure, I would love to. I think prompting is a whole topic on its own. We could do a whole panel just on that. The past 6 months, it's the whole how we build the application. It's changing so much with these prompts, and with tools like LangChain out there, it's very easy to get a POC out over a weekend. But now pushing that POC, pushing your idea into production, that's the hard part. And there are a lot of things that you can actually do with prompts. And let's take for example, one use case that everyone's been talking about is a document question answering system. And you can provide a lot of context along with the prompt that you develop. And this can be, document 1 with its URL 1, document 2 with its significant URL. But how the output comes out, you can always structure this output. You can prompt it, say, hey, I want this output in a particular format. I've seen that help a lot. Let's say you want it in a JSON format with XYZ and markdown tags. All these help. But another thing that also helps is adding examples, lots of examples, relevant context into your prompt has helped a lot for me, at least. It's a weak RLHF kind of a few shot examples that you can add within your context of your prompt, but not just adding examples of how you want this prompt to complete, but you can also get, a lot of people say, hey, I add examples that overfits to these examples. But another way to overcome this overfitting is by adding this relevant examples, the contextual retrieval everyone's talking about with vector databases out there. Fetch the relevant context, and you can provide a list of examples there, and you can do vector database search, semantic similarity search from what is the user's query, get relevant context, add it into your prompt, and that has, I've seen, do a great job there. Another thing when it comes to getting these LLMs into production is that I've faced is the latency, right? As you chain prompts, there's so many agents chaining of prompts. Latency has been a huge issue, and you can actually solve this by a lot of UX features. Depending on your use case, you can, streaming is a great thing that we've seen ChatGPT do. You don't feel the latency because ChatGPT keeps throwing you these messages. Another thing is you could split your prompts into multiple things. Like, for example, like document searching. First, fetch the documents, provide that to the user. Let the user look into the documents while you fetch the answer. So splitting your prompts and getting intermediate messages out there does wonders, and hiding the latency is what I've seen. And yeah, I think that's my overview, like a really short overview of like prompting tips that I've learned.
Awesome. Sahar, you have a take on that?
Yeah, I mean, one thing I found really useful for avoiding hallucination. So first, we know the normal tips actually like act as something. The way I think about GPT and LLMs is this huge tree of many activations in neurons, and you always want to help it understand what you expect it to do. So the more information you can provide within the prompt and help it know what path to activate, the easier it will be for it to help you in achieving your goal. So specifying the format and stating what role it should act is always been useful. One concrete tip for avoiding hallucinations within the prompt: in many cases, I think about LLMs as like these satisfiers. So they always want to provide you with an answer. So just by giving it an out, they will actually follow. So for example, if you want to classify an Amazon review as positive or negative, but maybe sometimes you're missing context or you're getting input that is not a review, you can always ask it to provide maybe like, say, otherwise return an A or error. And then by doing so, it will actually avoid hallucinating an answer that is actually wrong and return an NA or some other predictable form.
Talk more broadly about your experience combating hallucination. What kinds of things have you run up against at Stripe, and how have you approached it beyond this prompt trick you mentioned?
Yeah, so I mean, first, hallucination is where LLMs make up data that is incorrect, and I feel like what's the main difference between other ML and deep learning models before is that they do it really confidently. So it's really hard to tell if it's actually wrong or not. So that's one of the biggest shortcomings. Building up on Natalia's point, it's very use case dependent. So if you are working with a brainstorming partner, it's one thing versus building maybe a behind the scenes classification model or pipeline that will then have substantial downstream tasks. So first, about hallucination, understand what is your use case, what is the impact of a mistake. Then ways to mitigate hallucinations. What I've seen very useful is first giving the LLM an out, as I mentioned, but also prompt chaining. So there's like a few approaches like self-reflect, and also like another video I've seen recently, Smart GPT, where you basically ask a question, then you ask the LLM to criticize the answer as an expert in this space, and then provide even the resolution. And by doing so, it increases performance substantially at the cost of latency and cost. So that's another idea, like prompt chaining, and kind of you get an answer and you check if the answer is actually correct. And another option and mitigation path is actually citations. So forcing the LLM to quote the source for its answers is really useful for reducing hallucinations. And it will also allow your users or yourself to check if the generated response makes sense. So you can actually go to that page in that PDF and see if this makes sense. And lastly, I've seen, this is relatively nascent and recent, there is this research called LLM Blender from Allen Institute of AI, where they combine multiple LLMs. So each LLM kind of picks in different areas. So if you combine them all and know which one to call in the relevant time, then it might help you improve performance overall and avoid hallucinations.
Yeah, we're seeing a bit of that in some of our companies that are doing some more advanced work here. So Jasper, for instance, is a great example of someone who's actually using a Blender style model to basically orchestrate across multiple LLMs to just understand and produce the best results where there is effectively, sort of blanks in the latent space of the model. One of the other areas that we're also kind of noticing as a pretty significant amount of opportunity is where you can take, call it visualizations of the latent space of a model and be able to understand where there's effectively holes in the latent space. And the folks at GPT4All, the Nomic team, was actually doing some pretty impressive work here in terms of visualizing the latent space of the model and then helping understand where to introduce additional retraining runs to improve the fidelity of models over time. So that was a, call it, pretty exciting area that we're seeing opportunity, particularly when you're dealing with a lot more small form factor models that you're trying to train for domain specific purposes, like retraining based on where there's missing sort of elements of the data set to train the latent space properly is something that's exciting.
George, in one of the earlier sessions, Josh Tobin had this great point about the companies that we really admire for doing a great job with AI. Tesla was an example he gave. Didn't just kind of throw out this model and kind of declared victory. They built this continuous feedback and improvement loop around their product, and that's really the differentiator and why we admire those companies. What have you seen in terms of companies building these kinds of feedback and improvement loops around LLM-based models in the wild?
Yeah, I'm glad you asked that question, Sam. I think when you look at the best LLMs and just transformer-based architectures that are going to continue to evolve in this space, they're inherently all going to have some reinforcement learning associated with them, and whether that be a human feedback loop, a machine feedback loop, a human and machine feedback loop. I mean, just think about the fundamental difference between what we saw with ChatGPT early on and more recently, right? It wasn't just the fact like, okay, they started to kind of evolve the model itself, and why are there sort of so many less hallucinations around ChatGPT today? Well, it turns out that it is the feedback loop itself. It's the RLHF that improved the model effectively over time. So I think we're going to see quite a bit more, call it model fidelity, model improvement by the fact that there's just good feedback loops just naturally part of any sort of, call it model that's being built for the purpose of these domains as they're kind of improving the application experience around it. I don't think this is a journey where you kind of just send a model off into production and then never, call it, improve it beyond just introducing the next generation of the model. I think in most cases, there's going to be some kind of feedback loop for reinforcement learning that's going to continuously improve models over time.
And when we think about that kind of continuous improvement, it's hopefully relevant or related to some kind of evaluation metric. We've touched on evaluation previously. Sahar, dig into that a little bit deeper. What have you seen working from an evaluation perspective for these kinds of models?
Yeah, first I will start by saying that I'm still surprised how we are quite behind on evaluation as a community, like AI space. It doesn't prevent us from running fast and deploying things into production, but still there's something to be made there. I know that many folks are working on making evaluation better, like LinkedIn and other smaller startups, but there's still a gap. I feel like when it comes to evaluation, there are a few ways we go about that. So the first one is in an automated manner. So some papers have used LLMs like GPT-4 to score the generations. So because generations are more like open-ended, text more subjective, LLMs lend themselves really well. One useful tip is actually if you're using GPT 3.5, you should use GPT-4 to judge the inferior models. So using superior models to judge inferior models work actually surprisingly well. You also need to make really clear what are your kind of metrics and what you're measuring. For example, you might want to have a benchmark or a set of examples for hallucination, a set of more examples about like toxicity and what you define in your company as things that should not make their way into the user. You might want to have more performance, like product performance specific benchmark for your specific use case. So hopefully we will get more and more tools that help us streamline these processes. And I expect other players like LangChain, Weights and Biases also released a few tools to help us getting there. But still, it's a lot more manual than I have expected it to be at this point.
Smitha, what have you seen?
Yeah, I think I chime in with Sahar, like what he said. I think another thing to bring in is prompt versioning. That's been a big thing. Prompt versioning, like you change a bit of your prompt, it can change like the output of something that worked before and it deviates. So benchmark questions, that's been a big thing at Prompt Ops. We have like a bunch of benchmark questions that we have that we want to evaluate against. And another thing is that, like Sahar mentioned, you could have like GPT say, hey, do you think this answer is similar to the answer that I expect, right? And we could even do, what I've done before is have like a scoring method where you have, hey, this is the question, these are the keywords I expect in the output, right? It doesn't have to be the exact output, but these are the answer should be having certain keywords. These are the significant keywords, and you could check against those keywords. And the other one is you could do like a quick semantic similarity. Do you think that this answer is similar to this answer? Have a score, and you could have like a whole evaluation score like weighted against these. And another thing to make sure is that the benchmark questions that you have should span across multiple areas. It shouldn't focus. And as you find benchmark questions, just keep adding them in. And it's not gonna, you could keep running this maybe daily or at some frequency and see when it deviates.
Actually, I'm curious, Smita, how do you track all those feedback requests and responses from using something in production?
By feedback requests, do you mean like the...
You found a new case where your LLM is as expected. What do you do?
Yeah, so I think at that point you have that, what is that question that deviated? And I would think about like, what is the answer that I expect at that point? What did the user expect? And then I could add that to the benchmark, or I could even add, like, as I mentioned earlier, examples. My whole, like the semantic, like the vector store database, add some examples there to improve the, like the output at that point. And that's something that, you need to have, like George said, that you need to have this entire feedback loop, and it's all, there's no right way to do it, and there's nothing right now. So it's going to keep evolving.
And are you finding that you're able to put all that feedback back into the process through prompting or through RLHF, or are you also needing to apply heuristics, regexes, or whatever those might be to to enforce constraints on the LLM?
It's definitely a lot of like you mentioned, like regex matching. I think that's been a big thing, because it's not just going to be that the output, like it's not going to be that the output always is going to follow the same format, right? I'm going to prompt it to, it can go some way. So making sure that like maybe like a JSON format or like tags, things like that. I think like OpenAI came up with the function calling yesterday that they released. That's a huge thing that the model's been fine-tuned on. So that's where it's heading. People know.
Regex and heuristics as the dirty secret of all of AI.
Always has been.
Exactly. So we've talked about chaining, Blender pipelines, all these things. One of the the challenges that they introduce is these APIs aren't free. Whether we're talking about OpenAI or inference calls aren't free. So there's an economic component that's particularly important for folks that are trying to field products. Natalia, can you talk a little bit about how product builders should think about the economics of these kinds of models?
Key thing to understand, which I think everyone on this panel does, is that the more explicit detail and examples you put into a prompt, of course, the better model performance, as Sahar talked about, one of the ways to assuage some of the hallucination issues. But that means that you get, the more expensive your inference will get with those longer, more detailed prompts. So I think that's the first key thing to understand. If you think about OpenAI, they charge both for input and output tokens, depending on the task. It adds up But overall, prompt engineering is still pretty cheap and easy way to experiment as opposed to building a whole ML product. So I'd encourage people to really use prompt engineering. The next thing I'd say is set up your experiments and experiments are not free. So be very thoughtful about how you set up your experiments, make sure you're solving the right problems, set clear expectations depending on, like, I've worked in large organizations, which means a lot of alignment, a lot of buy-in. So you have to explain to leadership team, partner teams, what kind of expectations they should have from your experiments. Minimize the risks, time box your experiments, think about build versus buy, and have a clear data story. So I would say, all of those things, experiment in order to figure out your costs. And then I would say the second part is something we had already alluded to in the earlier conversations. Consider smaller models. Smaller models will be cheaper and there will be trade-off around accuracy, but that might be a really good way to minimize your costs. Those are my recommendations. I want to hear what other people think.
George, I was curious from George's perspective as an investor. You're seeing a lot of these economic conversations. How are founders kind of thinking about it and having those conversations with their investors?
Yeah, I'm glad you asked that. I think we're seeing, particularly some of the companies that are more, call it, earlier in their growth journeys. They're the ones that are experimenting faster and trying things in a way where they're bringing products to market in literally weeks, right? So I'll give you a good example. A mid-stage growth company, Honeycomb, is in the observability market, right? And they build, next generation observability solutions. They introduced a better query builder so that instead of, asking questions from a distributed tracing standpoint, using a very esoteric query builder to ask the question, they introduced a natural language overlay. Now, very, very straightforward to introduce something like that using a finely tuned LLM for introducing a product feature like that within weeks. And interestingly, that became, I would say, the most actively used feature inside of the Honeycomb product within 2 days of it launching. And wow. So that ability to just kind of try something, experiment, iterate, launch, and move quickly is something we think is a pretty profound opportunity, particularly for any startup that's going through this journey. We're also, by the way, just quickly finding the fact that a number of larger scaled out incumbents have a pretty tremendous advantage here, which is the private data itself. Over time, we don't think this is a moment where just incumbents will fall by the wayside because just generative AI movement is happening. It actually turns out they have one of the most important weapons inside of this sort of scale and capability that's going to occur in this space, and that happens to be the private data itself.
And capital.
And capital.
Sahar, you wanted to jump in?
Yeah, just adding on Natalia's point about how do we make it make sense from a cost perspective. Also, if you have longer context windows, fine tuning is also quite helpful. We have found that, so you can fine tune the model. It's a one-time cost you have to pay, but then future generations will have way less prompts and way less tokens. And then another meta point is usually what I've seen is we have two different types of companies, right? We have the enterprise companies, which so far I haven't heard from anyone working in this space, not only Stripe, but in general, that having cost is an issue. So given the impact it usually has on the bottom line business, and for enterprise companies, it's still not a blocker. For startups, I would encourage actually startups to currently kind of put this aside. Of course, there will be a path for this becoming cheaper and cheaper. If you look at the trend from the last 12 months or so, LLMs are becoming cheaper and more powerful. So I wouldn't let anyone kind of be blocked by these profit margins unless it makes no complete sense, and then that's a different thing.
Yeah, I totally agree there. Working at a startup, it's the cost isn't a huge concern right now because the value to the customer and the expectations of the customer is increasing. They do always expect hey, I just want to ask it in normal English, right? That's always been I don't want to remember this query language. That's one thing. And coming to Natalia's point about like the tokens, you are charged for the input tokens and the output tokens. So adding prompt engineering to constrain, right? Constrain your output. You could either say, like if your use case is like some summarization use case, keep the length to like a short extent, because we've seen that the completions can go on and on. So constraining it, having like the formatting, output formatting expectation that can reduce it, as well as semantic caching. If that's something that for your use case, it makes sense. If you don't need the completion to happen every time. If the similar question has been asked before, just get that output. You don't need to do OpenAI API calls all the time.
Just one quick observation I want to make. We're talking about costs, but in reality, for enterprise, they're at the very beginning of the journey where they're scared of the risks and even wading in. And so once they get past that, I think costs might be a consideration, but by that time, I think the costs will be so reduced. We're seeing every day, smaller and smaller models on edge. I'm super excited about an open source. I think increasingly, like the story on cost is changing very quickly. Costs are coming down very fast.
Yeah. I think we're coming up on time, but I don't see anyone here to kick us off. So
we're
take
past
on another question. Well, I think we're doing a service until someone comes and says they're ready for the next session. We did say we wanted to come back to model selection.
Feel free to do like one more question.
Okay.
Perfect.
We've throughout this talked about how there are new models emerging all the time. We just talked about how the models, there are smaller models, bigger models. Still, there are advantages to both of those. Sahar, talk a little bit about your experiences from a model selection perspective. How much time are you thinking about when you are approached with a new product opportunity? What's the right model to start with, and where do you start that conversation?
Yeah, so we usually think about it in two ways, right? We have the open source models and the commercial models. On the commercial side, and coming from more of an enterprise perspective, the number one factor to start experimenting is what do you have access to. So like getting something off the ground and working, let's say, with cloud from Anthropic requires agreement, the same way that OpenAI and Azure and all the other cloud providers. So usually, if I want to experiment, I will go with what's most available at this point. But then when it comes to performance, it's still like it all comes back to evaluation. That's why I'm so excited about this space. There is an LLM leaderboard, and there is also a leaderboard for vector databases and embeddings. We'll also post in the channel in the chat. So what we usually do, we start with something like GPT-4, which is usually the most performant. If it works relatively well, we can always downgrade because GPT 3.5 is cheaper, but more importantly, faster. So depends on the use case, but I would advise folks to start with the more powerful model, see if it works really well, iterate the prompt, and then potentially downgrade if it makes sense. Then when it comes to open source models, I feel like the more we will build our own evaluation, it's literally in the last 4 to 8 weeks, this amazing progress is happening, the easier it will be for us to also incorporate these models. And lastly, I will say, companies like AWS launching SageMaker, like with Hugging Face and other LLMs, but also Bedrock and these kind of generative AI capabilities help us all experiment a lot faster. So I would expect probably, I don't know, in the next 6 months or so, we will have a smarter engine/layer to allow us to plug different language models and experiment a lot faster. And then potentially using even more than one LLM for the same use case based on our latency requirements, cost requirements, and accuracy metrics.
Awesome. Demetrios.
What's up, everybody? This is angle 2. I'm trying to do both stages at once, which you can imagine is a lot of fun. And I've been listening in on this. Absolutely loved it. Thank you all for joining. I wanted to just come on here for this moment because I have to say, like, George, I've gotten to meet you in person. It was incredible. You blew my mind. And I hope to meet the rest of you, Asmita, Sahar, Natalia, and of course, Sam in person. But I wanted to just wrap it up with this, that if anyone is not listening to Sam's podcast, go and do that. He has been absolutely inspirational for me and this whole community, and so much help that I had to drop in here and tell everyone that, and because I know you're too humble to say that
Appreciate
yourself.
that.
So for the people that do not listen to TWIML this week in machine learning and AI, get out there, listen to it. We'll drop a link in the chat. And I know that I'm pretty sure most of the panelists are huge fans of this, and I'm pretty sure you probably got some fans out there listening right now. So thank you all for doing this. This was awesome.
Thanks, everyone.
Thank
Thank
you.
you.
Everyone.